Hello and welcome. My name's Kyle Roberts. I'm a senior technical marketing engineer here at F5. Today we'll be discussing F5's distributed cloud account protection services. Account takeover attacks are on the rise, along with increasing fraud losses. The account takeover attacks journey starts with automation, becoming more targeted with human-driven or human emulation attacks. F5's distributed cloud account protection stops manual fraud, and our AI fraud engine uses several main families of features to determine if an online transaction is risky and potentially fraudulent. Using a JavaScript tag, it collects hundreds of client signals per transaction and securely communicates with our API service to obtain real-time predictions on risk levels. The system uses families of proprietary features developed from years of analyzing fraudulent user traffic patterns. F5's unique approach to security and fraud provides a frictionless and integrated approach that prevents fraud across the entire user journey as the user interacts with the application. We know that any one signal by itself is not a definite indicator of fraud, but when taken together, they provide fast, accurate, and frictionless detection. The signals focus on three main aspects: user journey signals, which are high-risk actions like update passwords or mobile number; behavioral signals such as copy-paste, speed of entering a password, etc., as well as environmental insights. Is it a real browser or device? Is it spoofed? Additionally, account protection uses insights from our global network of threat intelligence, insights gathered for protecting over 1 billion transactions per day across a large number of organizations, allowing us to identify new fraud patterns faster, using telemetry across our global intelligence network. Now let's have a quick look at the demo environment for a preview of what we'll be showing today. Our account protection demo will begin with our first demo scenario of a good user logging into our banking application, then performing a money transfer. We'll observe the signals as they're collected and the risk score and actions for that user. Then we'll walk through a bad actor attempting to log in to multiple accounts on the banking application while leveraging some suspicious behaviors and attempting the same money transfer. Then we'll move into the Account Protection Console UI and investigate some fraud incidents like an analyst would do. From there, we'll view the insights regarding the AI decisions of that fraud alert and provide feedback into the system. Now remember, there are hundreds of signals that account protection looks at. However, this demo will only show a limited set of those. As the user moves around the application, account protection is constantly getting updated signals in real time. Make note of some of the signals we're able to see here: the device fingerprint, the number of accounts attempted by this device, copy-paste, interval between keystrokes, and so many more. Now let's log in as our user named Alice. Alice logs in often and performs weekly money transfers to her sister, so this behavior is seen as normal by our AI fraud engine. We have a slightly elevated risk score, but very normal user journey for Alice. This transaction has an action of allow. One of the signals that account protection uses to identify risk of fraud is high access diversity. Here we can see this bad actor with failed attempts to access multiple accounts. We see the accounts attempted by device signal is increasing, which changes the risk score and the recommended action as well. Eventually, this bad actor successfully accesses Alice's account with her credentials. As the fraudster tries to add his new payee and empty Alice's funds, he's presented with an MFA challenge which he cannot satisfy. He is then blocked, and this incident is recorded and presented back to the fraud analysts in the Account Protection Console. The Account Protection Console provides a smart portal for fraud teams to analyze fraud happening within their applications, so they can take action quickly and with confidence. Notice that we have a filter configured to only display transactions with a recommendation of block or suspicious, and we are sorting them by risk score from highest to lowest. If we look at the fourth line with user Bruce Wesley, let's expand the fraud reasons. We can see many of the signals that we demonstrated from our bank transaction demo earlier. Many account attempts, pasting text, and others as well. We can also see that in the feedback column, there is none yet recorded. You can provide feedback to account protection regarding whether or not you think a transaction is fraudulent, or if an entire user session that includes the transaction is fraud. This enables the AI models used by account protection to more accurately determine which transactions are suspicious and which transactions should be blocked. Now let's open up this transaction for more information about the AI decisions behind this event. Looking at the transaction, we see the summary displaying the risk score, recommendation, and fraud reasons. The event information has timestamp and URI info, and the user session information is showing this single transaction, but can display correlated events that share the same session ID and device ID. We also notice that the network information shows this transaction from Russia, which is not common for our application. This transaction looks suspicious, but let's go ahead and search our transaction log for this particular device ID and see if it can help our investigation on Bruce Wesley. We've copied the device ID, so let's add it to our filter. After the filter has been applied, we see 6 different accounts from this one device ID, all coming from different IP addresses and ASNs. Let's expand the fraud reasons, and we see many known fraud signals as well. We now have high confidence that this is a fraudulent transaction. Let's go back into the transaction and submit our fraud feedback. Let's walk through one more scenario where we submit fraud feedback for an entire user session instead of just the transaction. On the main dashboard, we see multiple transactions from this Lotus 12 account ID. Let's investigate by opening the transaction. When we look at the information, we see all the correlated user transactions and their associated fraud signals. This is an easy one for a fraud analyst, and we can go ahead and mark the entire user session as fraud. This demonstration showed how F5 Distributed Cloud Account Protection addresses many of the challenges of account takeover, and how F5 can help fraud teams mitigate, detect, and respond to fraud faster. I'd like to thank you all for viewing our session today. See you next time.